Hello guys, in this video we are going to discuss nature of graphs. Okay, nature of graphs. We have discussed earlier that we plot graphs of distance with time, or then displacement with time, or velocity with time, or acceleration with time. Correct? Distance with time. Now, distance with time, if that graph is, let us say, if it's a straight line, then that would mean that the speed speed would remain constant. I have a graph like this. This is distance and this is time. Okay, distance. Okay, I'm writing D here. I'm not writing S because S we would be using for displacement. Okay, if the graph is like this, that means that its slope of the graph, or the gradient of graph, is constant. Correct. So that means my displacement, my distance covered is changing uniformly. Correct. So at any point of time I would say that the speed is remaining constant. But now if I have, instead of distance, I have displacement here, and if I have a straight line graph, then that would mean that the velocity is constant. Okay. Now if I have, now for this graph, what would my velocity time graph be? Displacement time, and now I'm plotting velocity time. Okay, now you see here that the gradient is constant, so velocity is constant. That means I am going to have a graph like this, a straight line parallel to the time axis. Okay, on the contrary, suppose I have this displacement time graph like this, displacement and time. Okay, if the graph is like this, I would rather draw like this, not like this, not sharp vertical ascent. But now here, if you see, the gradient here and the gradient here and the gradient here, okay, gradient goes on increasing. Correct. Here it is more towards the time axis. Now it goes away and away from the time axis. That means my gradient of displacement time graph is increasing. That means my velocity is increasing. Correct. What does it mean? So my velocity time graph would be like this. My velocity, it increases with time. Okay, it may not necessarily be like this. Okay, my velocity may not linearly increase. It will go on increasing, but it may not linearly increase. But fairly I can say that it would be something like this, at least something like this. Correct. Now suppose instead of my velocity time graph being like this, if my graph is suppose like this, then what would you say about that velocity time graph? That means with the gradient to my velocity graph at different points, as the time is increasing, gradient of velocity time graph, it is going on increasing, right? And what is the gradient of velocity time graph? Is it not acceleration? If my velocity is constant, then my acceleration is 0. If my velocity is increasing, then and if it is a linear relationship, then that would be constant acceleration. Correct. But if my velocity goes on increasing, okay, the gradient of velocity time graph goes on increasing, that means my acceleration is also increasing. Okay, now so these are different types. But then can I have something like this, a graph for I have distance time graph. Okay, can I have something like this? Is it possible? This will not be possible. Now what is the reason for this? See, I said distance, I did not say displacement. Distance can be 0 or distance can be positive. Distance cannot decrease with time. Okay, it can be in some other direction, but then distance covered by a body with time will never be decreasing. Okay, so this will not be possible. Again, suppose I have distance here and time here. Okay, position time graph. Okay, can I have something like this here? Is it possible? Is this graph possible? Or like that? Again, it will not be possible, because if I have this, that means at t is equal to t1, let us say, my positions are d1 and d2. Is it possible for an object to be at two positions at the same time instant? No, it cannot be possible. What about displacement? Again, it will not be possible. We are going to discuss something related to speed. Okay, speed and velocity, and even displacement for that matter. For that, we'll consider the motion of an object thrown vertically upwards. An object thrown vertically upwards. Okay, so now what about the velocity time graph? Velocity time graph. As I throw the object upwards with some initial speed, correct? Then what happens? Its speed goes on decreasing, and then it will reach some maximum height, and from there it will start coming down, correct? And then the speed will go on increasing. So if I draw a velocity time graph, then from ground it started, its speed became 0 at the top, and then again it increases here. Okay, what about an object dropped from the top of a tower? Okay, in that case, what would happen? If it is dropped, then at t is equal to 0, its speed would be 0. It would increase and then it would decrease. Correct. Velocity would decrease. Velocity time graph. Now, for this object, what about velocity? Here, velocity it is speed with time. Okay. What about velocity time? Or if it is velocity time, then what is speed? Speed with time. Now here, if you see, this is speed. I'm going to draw velocity time. Okay. The object is projected from ground. Okay. It has got some initial velocity. Okay. And as it moves up, its velocity goes on decreasing, and at this maximum height, its velocity became 0. And now what happens? Now the object will start coming down, isn't it? It starts coming down. So while coming down, its velocity goes on increasing, but then it increases in the opposite direction. Okay, so now my velocity is going to increase like this. Correct? What was this? This was speed with time. Speed versus time. Okay, and this is velocity time. Correct? In the same way, you can draw the graphs for distance and time, acceleration time, and so on. Okay. Again, when we have a graph of acceleration time, then the area under the graph, that would give you velocity. Okay. If you have a velocity time graph, then the area under the graph would give you distance or displacement. Now, when to say distance and when to say displacement, let us see that. Very quickly I'll explain this. Suppose my velocity time graph is something like this. Okay, now here if you see, we want the area bounded between the curve and the time axis. Okay, now in this case, this is the required area, but then this area is above time axis, so positive, this is positive and this is negative, isn't it? So for velocity time graph, if I find the area bounded between the time axis and the curve, okay, and if I take negative sign here and these two signs positive, then what I get is the displacement. So now if I call this area A1, A2 and A3, then A1 minus A2 plus A3 will be displacement, and A1 plus A2 plus A3, that would be distance. So these are a few things that you need to really feel, you need to remember. I wouldn't say remember, but you should be able to feel it, what is happening there. Once you feel that, you will not have to memorize anything, right? In the next video, we are going to study relative velocity and the numericals related to that. Thank you so much.